Hello students, today we will discuss about chi-square test. It is the important test which is developed by the statistician. In this video, we will discuss about the introduction of the chi-square test as a goodness of fit, chi-square test as a test of independence, what is chi-square statistic, how to run the test, and what are the different conditions for the application of chi-square test. Symbolically, it is represented by the Greek symbol chi square and it is pronounced as ki square, means chi square. It helps in finding the statistical significance difference between the expected frequencies and the observed frequencies. Here, the null hypothesis will be the variance of the sample is equals to variance of the population. Variance is the square of the standard deviation. So here, the formula of chi square will be sigma s square divided by sigma p square bracket n minus 1, means you have to divide the variance of the sample with the variance of the population and then multiply it with the n minus 1, that is the degree of freedom of the chi-square test. Sigma s square is the variance of the sample, sigma p square is the variance of the population. And how we will conclude the result is when the calculated value of chi-square is less than the table value, then we will accept the null hypothesis and we will say that the variance of the sample is equals to the variance of the population. Next, we will study chi-square as a goodness of fit. It is a non-parametric test, you all know, and I already discussed it in my last videos that chi-square is a non-parametric test. It is concerned with the distribution of one categorical data. Here, one is very important because goodness of fit deals with only one categorical variable. So, the theoretical distribution is fit to the observed is checked through the goodness of the fit. So here the one word is very important. The null hypothesis will be the population distribution of the variable is the same as the proposed distribution, whereas alternate hypothesis will be the distributions are different. Here also, when the calculated value of the chi-square is less than the table value, then we will say that the fit is good, means the divergence between the observed and the expected frequencies are due to fluctuation in the sampling. For example, when a dice is thrown 186 times, then the number turned up and the frequency of that number is given in the question and you have to calculate the frequencies. Observed frequencies will be given in the question. Expected frequency you will calculate it by dividing 186 by the 6. Then you will get the expected frequencies. And in this way you have to solve the question. You have to put the values in the formula that I will narrate you later on in my next slides. Next, this is the formula for the chi-square test when it is applied as a goodness of fit. Chi-square is equals to summation of the differences of observed and expected frequencies. Then we will do their square and we will divide the value with the expected frequencies. In this way, we will be able to calculate the chi-square values. Here, the degree of freedom will be n minus 1. OI is the observed frequencies. EI are the expected frequencies. Here also the result will be the same. When the calculated value of chi-square is less than table value, then we will accept the null hypothesis. Second, we will study chi-square as a test of independence. It explains that whether or not two attributes are associated or not. Formally, the hypothesis statement for the chi-square test of independence are: null hypothesis is there is no association between two categorical variables. Whereas alternative hypothesis is there is an association, means the two variables are not independent. For example, if we would like to test to determine the relationship between the voting patterns and the race, income and gender, behavior and education, then we will use the test of independence. So here the one important thing that you have to keep in your mind is two attributes. In goodness of fit, we will study one attribute, whereas in test of independence we will study two attributes are associated or not. The chi-square statistics is chi-square is equals to square of the differences of the observed frequencies and the expected frequencies, and then we will divide the value by the expected frequencies. In this case, the degree of freedom will be r minus 1 multiplied by c minus 1. OIJ represent the observed frequencies of the cell in the ith row and jth column. EIJ is equals to expected frequencies of the cell in the ith row and jth column, whereas R represent row, C represent the column. Here the calculated value of chi-square if less than the table value, then will accept the null hypothesis. Here how you will calculate the expected cell value? That is equals to column total multiplied by row total divided by n. What is n here? N is the grand total of the values. Again, the calculated value is less than table value, then we will accept the null hypothesis, which means two attributes are independent or they are not associated. So this is the chi-square statistics in both the cases. Now, how we will run the test? First of all, you have to calculate the difference between the observed number of cases and the expected number of cases in each category. Then the differences is squared and divided by the expected number of cases in that particular category. These values are then further divided and the total value that comes will be the chi-square value. Next, you have to compare the table value and the calculated value, and then you have to make the conclusion whether the table value is greater or the calculated value is greater. So in this way you will run the test. But there are certain conditions for the application of chi-square test. When the observations are collected on the random basis, item of the sample must be independent. One group should have at least 10, otherwise you have to do the regrouping of the two different groups which are having the frequencies less than 10. Overall items must be at least 50, means minimum 50 should be there. In all, if all these conditions are fulfilled, then only we will be able to apply the chi-square test. I hope you all are able to understand now what are the basics of chi-square test. In my next video, we will solve two numericals of the chi-square test, one for the goodness of fit and other for the test of independence. Thank you so much for today. Like, share and subscribe my channel, and if you have any queries, then you can send a comment. Thank you.